Thank you very much. So love to know who is in the room whenever I'm speaking. So let's get a little bit of interactivity here. Put your hands up if you've played around with generative AI at all, like even just the slightest. Cool. Put your hands up now if you are a musician, if you play an instrument or have ever played an instrument. Awesome. Put your hands up if you play folk music or are a Morris dancer or dance folk music or any of these folk-related disciplines. Okay, welcome Morris dancers and those of you who are maybe unwilling to admit to being a Morris dancer, but you're welcome. You're in a safe space today. So as mentioned, my day job, I work for Coefficient. On the side, I do things like help to organise PyData London, this beautiful community. But I also have another passion that I'll be sharing with you all today. Now, to some extent, this is a music-themed talk, but to a large extent, this is an NLP talk in disguise. So let's talk a little bit about the methodology I'm going to be introducing to you today, which is a generative AI approach to topic modeling using embeddings. So this is the first demo I'm going to be putting together, and we're going to work through how we get to this. This is another side hustle of mine, electoral political data analysis. And we've had some manifestos this week in the UK. We've got the Labour manifesto, and they've put out lots of words, and whenever I see words, I think, cool, let's do some topic modeling. So maybe there are different ways that we could have done this historically, but the approach, we're going to figure out how do we actually get to even having these topics. How do we start to understand things almost instantaneously without any human intervention that Labour is prioritising, for example, restoring order and stability, whereas the Conservatives just throwing out policy initiatives and commitments. That's the biggest theme in their entire thing. So step one, get some data. We've got some PDFs. We can scrape the PDFs, we can get text. Once we've got the text, we can load that text into Python somehow. So we're going to load it in. Now, what you want to do if you're going to embed anything is figure out how large can my embedding chunks be. So some slightly messy pure Python code here to effectively chunk through text, split up into first of all paragraphs, and then figure out how much those paragraphs need to chunk into. So in this case, I'm going with tokens in air quotes, it's words, but up to 500 words in a chunk. And then that chunk is going to get embedded. So you can see on the right here, we've got some of my Labour chunks, the Labour chunks from the manifesto, and it's a pretty big chunk. These are 500 words long. So you could play around with these to suit your needs, whatever you're doing, but that's what I'm doing for now. Then we want to embed the chunks. Now, there's lots of approaches you could take here. There's local, sort of private embedding systems you could use. You could use things like Chroma, which comes with its own embedding tooling. You could use the top embedding systems, the NVIDIA one that's currently smashing out the leaderboard on the embedding leaderboard. I'm being lazy, because this is not really a talk about embedding theory. It's a talk about more things than that. So I'm just using the straight-up OpenAI text embedding 3 small. But by and large, very easy to use. Throw it some text, tell it what model you want to use, and it will respond with a slightly overly complicated objects you have to dive into to get the embedding out of it. But once we've got that, we've got large vector of numbers that represents that big block of 500 words. And that is 1,536 numbers long, basically. That's the length of the vector. So then we can do some clustering on those embeddings. So you've got a big vector space. What can we do with it? So we can throw it into a clustering. Again, you can optimize your clustering technique. You can fine tune it. You can do so much with it. But let's start simple, keep it basic for now. K-means, not even going to parameter tune the number of clusters, just going to say, right, give me 8 clusters on those embeddings. Does it even work? Does it give us anything sensible? I guess that's where I'm looking at the moment. And we get something out of it. We get Labour's most popular cluster is number 6. Thank you very much, clustering. Apparently the same with Conservatives, also number 6. So then we can do something. Now in traditional NLP world, we might want to run this through various topic models. You could throw it through some bag of words, TF-IDF the hell out of it, throw it into LDA or whatever your topic model du jour is. But this is a very, very lazy NLTK approach. So I'm not going to go through the detail here. It's just rough and ready. NLTK, remove some stop words, remove some punctuation, and find literally just the most popular word in the overall cluster. So for each cluster, it still gives us some explainability into our clustering. Now we've got the idea that Labour's sort of key word in cluster 6 was work. Okay, so we've got some insight into this strange embedding clustering thing. And we get some ideas of maybe what is being prioritized here. You've got the Labour Party prioritizing work, government, energy. They've got their big initiatives on that front. The Conservatives much more around the UK, people, local, tax. You actually get a real vibe immediately off the bat from this clustering of an embedding of the manifestos, what is important for each of these political parties and what they're trying to get across in terms of their vision for the country. But this is so like 2015. We can do better than this. So let's name the clusters with transformers. Let's use amazing kick-ass generative AI technology. And again, there's lots of options you could go with here. You could use your favorite local LLM. You could use Llama 3. You could use Phi 3. If you want to see more about that, check out some of my other talks on YouTube. I am going simple for this talk, and I'm just using OpenAI, slightly, again, convoluted API, where you have to dive quite deep into the responses to get out your single output. But what are we doing? We're basically saying, summarize the following texts, and those texts are all of the chunks within a cluster. Okay, so we take all of that cluster chunks, we concatenate them all together, and we just say, right, summarize this in one simple, short topic name. And it gives us some topic names, and they all need a little bit of cleaning up, but after some cleaning up, we get to the sort of pie charts that you saw before. And so we really get this understanding into a much more nuanced feeling. What is it that they care about? Each of those areas. Now, this is a pretty weird demo, I'm not going to lie. What is the value of doing this sort of thing? So I'm going to give you an insight. I've used this for survey analytics, and it's absolutely amazing. If you can have survey raw text response data, works well with traditional topic modeling approaches as well, but this sort of approach, I've really found it to work well, and you get intelligently named nuanced clusters, much better than these are the keywords or the key phrases that represents this cluster, and you then have to reinterpret that with your human brain. We can get transformers to do it automatically, which means you can productize this stuff as well. And when we get these clusters with survey data, then we can start diving into, okay, which demographics are overrepresented in each of these clusters. So if you were seeing the same sort of stuff, but coming out of, say, for example, large-scale opinion polling data, you could really understand which parts of the UK most care about cluster number 6 here, the restoring order and stability, which people really care about change, which people care about the NHS, which people care about, for example, the tax initiatives that are coming out. And that would be pretty useful, whether you're a marketing agency, whether you're a political party, whatever you're doing, whether it's using raw text data, being able to take your smartly named intelligent AI-generated clusters and then start looking into the crosstabs and understand then what actually drives, what's the causal links between someone expressing an opinion for one of these areas or topics. So that's the power. That's the real, if there's one good takeaway, if you work with raw text data, try out this technique. I'll put all the code on GitHub afterwards. And again, because politicians love pie charts, same thing, but as a pie chart, just to offend all of you. So there's more that we can do. We can actually get really deep into the embedding space. We can start to understand, okay, we've got clusters, we've got these clusters intelligently named with transformers, but we can do so much more. Let's see how those clusters relate to each other. So I first wrote this talk using just Tisney because I'm not worrying too much about the methodology, and then everybody spent most of yesterday saying how rubbish Tisney was. It's really fun to say, but I ended up rewriting the talk using UMAP because it came up in a keynote, and then it came up in a pub quiz, and some of you corrected me as well. And so, yes, let's use UMAP. The benefits are better structuring of both the local and the global level. Tisney over-focuses on the local. Also, UMAP, more scalable. So for 3 good reasons, check out UMAP. Very easy to use, though. We're just going to throw in that massive list of embeddings as a NumPy stack. It's basically a big old matrix at this point. We throw it into UMAP. We say, give me 2 components, and then we're just going to visualize those 2 components, dimension 1, dimension 2. Oh yeah, we've got some lovely GIFs showing you what UMAP looks like. A better projection system, so to speak. So with a little bit of plotly and a scatter plot, we get beautiful UMAP embeddings of our manifestos. So again, we can see what is similar across this. These are all the individual chunks. Remember, 500 words per data point. And there we can see, okay, there is some semantic similarity between NHS and healthcare reform plans in the left here versus, for example, in the bottom, you've got environmental action. Further away from in the top right, you've got economic and energy. So there is, again, some sort of semantic meaning in the embedding space. And the same, again, with with the other manifestos. And we can actually, with Plotly, interrogate these. We can get into those individual data points and we can confirm that this is an absolute nonsense, because as I was going through this the first time thinking, does it make any sense to just cluster a load of embeddings and stick it into Tisney or UNMAP? Turns out it's doing something sensible. You can sort of sense check this. So same with conservatives, and again, we get the idea of there are semantic spatial relationships. Some of these topics are closer to each other than other topics. So again, in this case, national security, closer to comprehensive social and economic policy reforms, like the hard-hitting things, further away from their maybe trade, defense, energy, agriculture, and education topics. Okay, so that is the technique. And I'm walking you through it because we're going to now go through it one more time, but with something wildly more fun, which is what happens if we do exactly the same thing, but applied to music. So where do we get data from in the world of music? So I am a folk musician, have been for a while now, and the wonderful thing about folk music is someone, a while ago, came up with a website for folk musicians to connect online. It's called thesession.com. You can find folk tunes. You've got Drowsy Maggie here. You can see the dots, as they call it, the sheet music. But you can also see a text representation of that entire piece of music. Now, this text representation, it's called ABC notation, and it was invented by a chap called Chris Walshaw, 1993, based in London here. You can find him playing his instrument at any good folk festival. And he wanted a system to notate music that was human readable, much more so than MIDI notation, but was also could be converted into the sheet music format. And actually, it's quite extensible. People have written Beethoven's Symphony No. 7 in ABC. In fact, so many things are now able to be encoded into ABC notation. And what you can see here is you've basically got some metadata, a name, a key, some time signatures. We're going to talk about time signatures in a moment. And then you've got the dots, you've got the notes. So for example, E above high C for two semiquavers. And then you've got a B and an E. And from that, you get a piece of music. So here is another example, ABC notation. In a popular response to another person in the room asked, can it do Super Mario? So I looked for it on the wonderful Folk Tune Finder, another website created by Joe Wass in Oxford. And yes, there's someone has uploaded somewhere on the internet Super Mario, which is really cool. Another thing, just while I'm on the topic of the folk music world, I think for those of you who are passionate about open source, there's some really nice interlinks between the open source movement and folk music, which has been doing open source for like hundreds of years. It's a musical tradition which is an oral tradition. All of the older traditional tunes, they're basically Creative Commons. They are shared from person to person, often orally, but now it's moved into the digital space. And you can find a lot of this stuff, maybe not Super Mario, but those older tunes shared with complete open licensing. So a really nice crossover there as well. Even better, it turns out quite a lot of folkies are techies. And this chap, Jeremy, in Brighton, took the entire website of the session, and every week he uploads the entire lot onto GitHub in machine-readable formats. So you can download all of the folk music tunes, at least on that website, which is most of them, as a single JSON or CSV download, as well as things like popularity statistics, how many people have added that to their tune books, where's the nearest session. If you wanted to go to a session after PyData London this evening in London, you can probably find one. Sunday's a great day for sessions in London. So really useful. These people are making my job possible. It wouldn't be possible without any of these innovations. So let's repeat the process. Step one, get some data. I can load in that CSV of tune data. And what it comes through in pandas, sorry to the Polish people in the room, in pandas, is we've got the metadata, and then we've got the ABC. Those are the dots, those are the bits I really care about. We can then chunk the data. So we can take just that ABC. I'm not even going to feed the embedding the metadata. I'm going to make it work for its dinner. And I'm going to throw this into an embedding model. By the way, I'm using joblib memory to cache this. If you're not using things like joblib memory to cache your OpenAI calls, really recommend it. It will save you, basically, if you're going to throw the same thing in, joblib will give you your local cache back out again, which is going to save you a lot of dollars. If you're doing web scraping, if you're doing any API calling, just check it out. There's a little usage tip there. So we're going to take that, we're going to chunk it through. I'm dividing those ABC responses into big old chunks and sublists. These are actually one row per ABC, but I'm taking 200 rows at a time, so 200 tunes at a time, feeding that into the OpenAI embedding to embed, because it can do sort of vectorized embedding, 200 items at a time. Taking that back and then sticking all the data back into my data frame and caching it along the way. So for each tune, we now have a big old vector, 1,300-ish numbers long, and we can start doing the clustering. And at this point, I actually did spend far too much time optimizing my clustering, fine-tuning the rest of it. So I tried out k-means, affinity propagation, agglomerative clustering, Gaussian mixture models, iterations on Gaussian mixture models to reduce clusters, bisecting k-means. I went to town. There's a lot of things that maybe actually happened behind the scenes to feed into this talk to try and get the best results. So honestly, I did my jobs to try and do a good job here, using silhouette scoring to optimize it. And with that, I found a reasonably good clustering mechanic that works for ABC folk tune notation embeddings and tried it out. And then I fed those clusters. This is, again, each cluster then represents maybe several thousand folk tunes. There's actually 21,000 unique folk tunes in this data set that's been fed into this. So each cluster, maybe 1,000 folk tunes. Those embeddings get fed into transformers, and we basically say, right, give a name for this group. And it comes up with some slightly wild and wacky names, but these names are meaningful. Again, it didn't get the metadata. It's just getting the raw ABC notation, and it's sort of figuring out music theory on the fly. Now, the first time I tried this, I was kind of amazed. I was surprised, maybe I shouldn't be surprised anymore, that OpenAI is somewhere in its data set, it's sucked in a load of ABC notation, and it knows what it is. It knows how to generate it. It knows how to read it. It's pretty phenomenal. And so when you give it just a string of text, it can say, yeah, that's a real in D minor, or that's a D major heavy folk tune. The apostrophe, the hyphen there is on D major heavy, not a heavy folk tune, although there are some really good heavy folk tunes if you want to look into those. Or B minor clusters with complex configurations. And then this sort of catch-all bucket at the bottom here, which has said, diversity in clustered folk tunes. Upon examining the tunes provided, there's considerable diversity in keys. It's trying really hard. It's written me a little essay here to try and back out its like bag of generic tunes that it doesn't know how to categorize well. A rich, varied tonal landscape prevalent in, I think it's trying quite hard there. So I've simplified those down a bit. I've just cleaned it up, and I'm just calling that group diversity, the diversity group. And we can then throw that into UMAP. And we can start to figure out where these tunes lie in the embedding space of music. A little bit of an aside now. A primer on folk music. You've got jigs, you've got reels, you've got hornpipes, you've got waltzes, you've got slip jigs, you've got 3/2s. There are so many different tune types here, and it's kind of useful for you to understand what these mean, because that embedding space, if you're thinking, oh, I wonder what dimension 1 means, it kind of encodes for different types of music. So when a long time ago, I used to work with a folk arts youth organization called Shooting Roots, and we came up with a system for teaching folk tunes. So the system is biscuit themed. The reel, it's a 4/4, and the rhythm of a reel is the Garibaldi, 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 Garibaldi rhythm. It's in 1, 2, 3, 4 Garibaldi. So when I'm talking about reels, think about that rhythm. Okay. When I'm talking about jigs, these are more like a gingerbread, 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 gingerbread rhythm. We call it 6/8. It's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. The 8 means it's kind of fast notes. Okay, so we've got the gingerbread jig. What else we've got? We've got hornpipes. Hornpipes are more of a jammy dodger, jammy dodger, jammy dodger, slightly swung, jammy dodger, 1, 2, 3, 4, jammy dodger rhythm. Then we've got the polka. These are shortbread themed. So shortbread, 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 1, 2, 3, 4, 1, 2, 3, 4, shortbread, shortbread, shortbread. This is making you hungry. You're going to have to wait. Then we've got the slip jig, which is maybe one of my favorites, because it's the gingerbread themes, but it's a gingerbread, gingerbread multi-pack, gingerbread, gingerbread multi-pack, gingerbread, gingerbread multi-pack. So it goes in 3s, or technically 9s, 1, 2, 3, 4, 6, 7, 8, 9. Gingerbread, gingerbread multi-pack. And finally, we have the waltz, which if anybody actually has a better, we're sort of 10 years into this system, we still haven't found a good waltz-relevant biscuit. But I do quite like the Walls ice cream, Walls ice cream, Walls ice cream, Walls ice cream. 1, 2, 3, 1, 2, 3. So you've got your Garibaldi, Garibaldi, gingerbread, gingerbread, jammy dodger, shortbread, shortbread, gingerbread, gingerbread multi-pack, waltz ice cream, your different types of folk tunes. Okay, so you're all folk music experts at this point. So let's explore just a small sample of the tunes in this embedding space. Okay, so if I look in the bottom left here, we've got a tune. This is the Flat World Waltz by Andy Cutting, has been stuck in the bottom left. Now, this is where things get kind of tricky. If you're trying to explore an embedding base of the embedding space of music, you can just look at these things, but it's just dots on a page. It's just it's almost meaningless. How do you understand, how do you viscerally, qualitatively understand why the purple tune in the bottom left here, which is in the diversity cluster, is different to the blue tune in the top, which is in the jigs in 6/8 A Dorian key cluster? And realistically, we have to be a musician to begin to understand it. Now, if you are playing around with this, if you find these tunes on the session, just below the dots, there's actually a wonderful button. It's called play, and it will play the tune to you. But it's a little bit robotic. They could do with maybe some Gen AI versions of this to make it sound beautiful. But it's still pretty good. You can still hear it. You can listen to it. But it's much more fun if you can just play these for yourself. So this is what we're going to do. We're going to explore the embedding space together of folk music. So Flat World, this is a waltz. Remember, the walls, ice cream, walls, ice cream. I'm just going to play a little sample of Flat World for you now. Okay, so this is Flat World, a beautiful waltz. Thank you very much. Thank you. So remember how that feels. You've got this beautiful 1, 2, 3, 1, 2, 3. Slightly melancholic. It's in a minor key, in the key of, I think, B minor here. So think of that as you look at the bottom left, melancholic, waltz in 3/4 minor key. So how is that qualitatively different if we move into the center? And we've got a Dorian Amixolydian tunes cluster in orange. It's further along dimension 1, slightly higher up on dimension 2. Now this is the Zakynthos jig. Okay, so we've got that 6/8, 6/8, gingerbread, 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 gingerbread. A little bit of positivity in some parts of it, still a little bit melancholic and jazzy. It's inspired by Brazilian rhythms in other parts of it. So slightly further along dimension 1. But what if we keep on going? We can go all the way to the top now. This is the jigs in 6/8 Dorian. And what you'll hear here is the key is very different. When we say key, think of sort of, does it make you feel happy? Does it make you feel sad? How does it make you feel? So this is, you're going to notice it's a different rhythm. It's a polka, short bread, and it's definitely a different key. So wildly happy, really, really cheery. Countdown races, known to people across the pond as probably like Yankee Doodle, very, very happy, cheery polka. So qualitatively different in the semantic space. And if we go all the way to the end now, we've got something that's interestingly, it's still a jig. So it's still that 6/8, 6/8, but it's a different vibe to it. If we go down again on dimension 2, on the y-axis, you'll see that it's back in that sort of melancholic vibe. So it feels, if I was interpreting this, that we've got these two dimensions. One seems to have encoded vaguely for rhythms, and one seems to be encoding vaguely for key, which is interesting because those are actually two of the most important bits of metadata for any piece of music. So finally, let's hear Out on the Ocean. This is a jig all the way to the right-hand side on dimension 1. So that jig, slightly slower in terms of how it's played. But again, maybe you're beginning to understand what does it mean to qualitatively explore this embedding space. So we can do more. We can now start to play around with the UMAP embeddings, and we get this absolutely beautiful map of the entire world of folk music, 21,000 different tunes represented, color-coded, and we can further explore and understand. Now, for me, we talk a lot about AI. We talk about the feeling that there are hopes, there are dreams, there are fears around what AI will mean for us, especially in the music industry. What will it do to everyone's jobs? Now, for me, this is a really exciting thing because this is a tool that we can use, especially because it is interactive. It's a tool that I can use as a musician looking for that next tune to put into a set, to play with my band. And I can play around with this, and I can explore and discover new pieces of music. It's a really cool way to be inspired, to find things that might go together, and to have the AI become an assistant, whether it's a compositional assistant or whether it's an arrangement assistant. That is the beauty of the future that I see. Now, there are many potentially less positive angles that AI could go in for musicians, but this is certainly one of the upsides, and I do see that future coming apart. And also, I just think if you add a little bit of alpha and blur, it becomes just great wall art. So, very nice. But again, we can see that there are sort of patterns, there are clusters. You've got your 3/4 waltzes in the bottom left there. You've got all the way on the bottom right your D major heavy folk tunes, your countdown races, your heavy polkas, all the way at the top, the predominantly G major tunes. So there are clusters that somehow the OpenAI's embedding model has encoded and it understands. I think that's really cool. And if we're showing off a bit, then we can also put this into a 3D Plotly scatter plot and really play around and see how this looks. Dig into it, zoom in, drag it around, explore what it feels like. And maybe this is almost an encoding of how folk musicians would see it. If you got into someone's brain, I'd love to imagine this is how they think as well. So what can we do with all of this? You can actually take this quite a long way. So we can start asking questions. We've got embeddings. There's so much we can now do with this as machine learning engineers, as data scientists. How far can we take this? And the answer is some distance. So remember Super Mario? Prashant said, hey, what's the most similar folk tune to Super Mario to me yesterday? So I said, I'm going to find out. I'm going to do the vector embedding of Super Mario. I'm going to find that ABC, I'm going to embed it, I'm going to then do a cosine similarity and find out which tune is most similar. So Super Mario, just so you can get this in your head, because is there even a folk tune that is similar to Super Mario? Again, you don't have all bits of folk music, there's only 21,000 tunes, and thesession.com is they've got quite a strong culture of if it's not a folk tune, it's not allowed in. People are quite strong, or opinionated there. So Super Mario, you've got the idea of Super Mario World. So just remember that rhythm, because that little snippet actually might come up again. So Super Mario, what is the least similar to Super Mario? That cosine similarity across 21,000 tunes, I actually found this fascinating, because what it came up with was something that is, actually it's just got loads of extra stuff in the ABC. I don't know, this is partially the tune. The tune, you'll hear it and you'll think, yeah, that is quite different. But also, ABC notation, I didn't know it can do lyrics. So someone's encoded lyrics into this tune, and I think that's also, it's qualitatively different, not because of the music, but because of all the extra chords and lyrics that someone's jammed into that ABC notation to generate this. But this is The Blacksmith. It's a real sort of slow, heavy, hardcore reel. Yeah, rock on, The Blacksmith. So very, very different to Mario qualitatively, and also those lyrics are probably one of the reasons it really scores poorly. It's got a very, very large distance on that. What about the most similar? So it came up with something absolutely wild, a tune, a 3/2 called Flow in the Year of Wu-Wai, which has been added to 8 tune books. So I would love to know more about this. This absolutely strange composition. I wonder if it is AI generated sometimes when I've been playing this. So I'm going to just play some little snippets of this that I think actually maybe this is where the cosine similarity in the embedding layer is coming from, but I think your mileage may vary. So I'm going to go halfway down on the right-hand side here. but it's got this slightly quirky rhythm. If you think about, okay, what is the embedding thinking about? Is it the melody? Is it the rhythms? Well, one of the classic things with Super Mario, that it's very like jumpy and skips around. It's got these rests in weird places. The emphasis is all over the place. And you've got a little bit of that in there. So maybe that's what it's looking at. But who knows how this embedding model is thinking? I am desperately trying to do explainability on folk music embeddings here, and this is about as good as I've got. So what else can we do? We can actually take those embeddings and take them into a whole new direction. And this is the Rexis angle of data science applied to tune popularity and embeddings. So the session.com, it's a sort of community website. People can add tunes to tune books. You can figure out what are the most popular tunes. So that's Flow in the year of Y is got one recording, which I'm going to have to go and listen to now, added to 8 tune books. So on the lower end, the Out on the Ocean, the jig that I played you earlier, is actually very popular, 3,700 tune books. And one of the most popular tunes, Cooley's Reel, is 5,600 tune books. And that's an absolute banger. Like really, really fun. Like if you're in an Irish bar, that's what you're going to get with Cooley's Reel. So you've got these popularity mechanics, and I can take this data and I can start building a good old regression model for this. See if I can build a tune recommender. So this is what I did. Read in all that tune popularity data. Take the embedding stack. Call that X. Take the popularity data. Call that lowercase y. Throw it into a good old hiss gradient boosted regressor in scikit-learn. See what happens. What happens is mixed, but it's picked up on something. So it's picked up on there are some tunes it's accurately predicting well. Now, it turns out that I took this quite a lot further. You want to do things like log normalize your y vector. It's completely not normally distributed in any sort of array. And there are lots of ways to improve this. But even with this basic version, we can begin to ask interesting questions around popular tunes. Again, 0.14 on the R squared, it's picked up on something. It's better than 0. So we can say questions. This is where I love data science. When you're building a regression model, again, top takeaway. If you're building a regression model, try and figure out its biggest failures. Find out what it thinks is the most over or undercooked prediction, because that will help you to qualitatively understand why your model is going wrong and what you can do, what it's missing, which bits of information it's missing. And it's just really fun. It's really fun to actually get into the business side of your machine learning. So in this case, what tune is the most overrated tune? The prediction model thought this tune should get almost 0 votes, and it actually has 3,000. And I found this hilarious because this is, it turns out, Harvest Home, which is one of the most overplayed tunes. I think it's okay, but it's just a bit overdone to the extent that my mother, when you're listening to this back later, she used to tell me this is her least favorite tune when I was growing up. So Harvest Home, it's okay, but it's just a bit overdone. It's very jaunty, it's very jolly. There's not much to it, especially if you've heard it 2,000 times over. Harvest Home, maybe over. I love that the AI is backing up the folk world on this. What is the most underrated tune? Again, AI is a companion for music discovery, is one of the coolest things. And I'm really looking forward to playing around with this, to just discover new things to play when I'm practicing every day. So this is the Rakes of Portland Street. There is 2 tune books. And yet my little AI thinks, this is a really good tune. And so this is a Gingerbread multi-pack slip jig. A fun tune. I like this. Thank you very much, AI, for suggesting something that I would have never have come across before. So we can also do other analyses. We can figure out, okay, in aggregate across these clusters, which tunes are most unpopular, most popular. People love jigs in 6/8 and A Dorian. People apparently don't like the reels in D minor for whatever reason. So understanding, exploring this would be really fun. But for my last trick, we can just do one more thing. Let's take all of that ABC notation. Let's try and build a tune generator using LLMs. Why not? It's 2024. So take one. I actually just started off with the ABC for, again, one of those popular tunes, Out on the Ocean. Just remember that, because these are going to be iterations, almost like a genetic algorithm, iterating on top of that. And so I started off with a prompt. I will provide you with a folk tune at ABC notation. I want you to improve it I don't want any response other than your improved tune in ABC notation. So trying to just get it to improve on a tune. This was my take one. And honestly, it just immediately got worse and never recovered. Now, my scoring system here is also a really bad His gradient boost regressor model, which is pretty rough and ready. But still, as an exercise in doing very silly things with LLMs, it seems to not be improving. So take two, again, these slides will go online at some point, so you can look into this absolutely wildly detailed prompts. I looked into the sort of tunes that were coming out, and I really, really went hard on prompt engineering to try and improve this. And take two, bit of a roller coaster. Now remember, it starts at 56. It doesn't really improve meaningfully above that. So take three, I'm not even going to play that because it's just really boring and a bit rubbish. Take three, I tried so many different things. I went into more iterations. I improved, instead of updating and iterating on just the last tune, I went on the best tune so far. Tried to get something that's more monotonic increasing. I started using better regressor models, so using log tunebooks and improved XGBoost model, exponent transforms, and so much more. And it was just so much worse than any of the things I tried before that. And again, this tune, it's just got nothing to it. It's just repetitive. It's not interesting. I mean, the XGBoost regressor, it's onto something. It's really just an uninspiring tune. Take four, I went to 100 iterations. I added loads of exception handling, so OpenAI didn't fail on me, or when it does, then it would handle that. And I simplified the prompts massively to focus on creative rewriting, just really simplify the prompts. And I stopped telling it all the wider goal. It's like working with someone, something, just tell them what to do, don't give them the entire backstory. So that actually works really well. I get a score of 71. So I'm just going to give you some excerpts from this beautiful score that is written. It's even given a name, Enchanted Folk Rhapsody, The Awakening, traditional but transformed by AI. Not maybe the world's greatest tune, but I feel like it's getting there. It's learning. So that is it. Thank you very much for your time. If you'd like to see me play, my band has some gigs coming up. Thank you very much.
Thank you, John. We can take a question or two. So does anyone have a question? Hey, yeah, great talk. I just want to ask about the notation. You ended up using ABC notation. Did you try any other notation to maybe find any other quirks about this sort of music, or maybe come up with different scores?
So I think I was completely amazed that LLMs could even understand ABC when I first started doing this, and they really, really understand it. This is actually, there's a potted history of generative folk music with AI. Years and years ago, there were people that were generating tunes with RNNs. They did a so-so job, then they got better, and then LLMs came along, and they just absolutely really smash it out. The tunes compile. You could probably do this with MIDI, but I think MIDI is a much fiddlier notation format. There are so many different ways that it can go wrong where it will not compile. ABC is more robust. The way I think about it, it's a bit like getting an LLM to write SQL versus interacting with a semantic layer with function calling. The space I guess the attack space where it can go wrong is smaller. It's got less things it can do. It will always work with the semantic layer, and the same is true with ABC. There are less things it can do. It will always give you something that compiles, so to speak. I think if you looked at MIDI or other notation formats, you don't get that. So more robustness.
So I think that's the only question we can take for now. John, will you be here for the rest of the day?
I will hang around immediately afterwards, so do come along and ask me questions. Otherwise, I'll be around all day. Thank you very much for listening.